Hello, my name's Ryan Howe, and I'm part of Team Eagle Eyes, and we're building a topographic mapping drone. The purpose of our system will be to map disaster zones and nature areas where it's too hard for humans to get easily. Recently, in the last few decades, LiDAR systems have gotten both cheaper and, importantly, lighter to the point they can be put on UAV systems. However, they range in price from $30,000 to $50,000, which is far too much for the average individual or municipality. To this end, our team has developed a topographic mapping drone for less than $8,000 that will be able to fly for at least 15 minutes autonomously in these disaster zones.
Hello, my name is Bilal Amri. I am the design lead on the Eagle Eye team. Design the drone. So I want to talk about the mount design for the battery and the LiDAR. This is the first version we are in with. It was meeting the requirements for the manufacturing. Then we scaled it down to the prototype version, which is mounting the smaller battery, smaller LiDAR, and mounted with the 45 degree as the tech team requirement. This will be scaled up to the final design.
Hi guys, my name is Hui. I'm the tech lead of Eagle Eye team. Basically, I'm the one who is responsible for all the parts that go into the drone and making sure that this little guy right here be able to carry the certain weight and be able to achieve the target flight time. Right here we have a typical DIY drone that we built for our prototype design, which is comprised of some propeller, some rocket motor, OY to some ESC to control the current go through them, and they all connect to a power distribution board inside the drone, plus like several controlling units as you can see right here and around the drone, and the GPS module as well. Plus we have a companion computer Pixhawk 4 right here to control all the LiDAR application. And at the heart of our drone is the Pixhawk 4 flight controller that coordinates the collaboration between the drone motor so that it's able to fly in certain directions smoothly. Without this black box right here, it would not be a pleasant flight experience for our flight test guide.
Hello everyone, I'm Vivek, the flight test lead. So after assembling the drone and all its components together, we used the QCloud control software in order to control the drone autonomously. In the software, we set some waypoints which the drone had to follow while flying autonomously, as well as we also gave it a set of parameters such as the altitude it was supposed to fly at and the time it would hover in the air. After turning the control knob to mission mode in the software and on the remote control, the drone flew completely autonomously and was able to fly for a total of 11 minutes as calculated by us.
Hi, my name is Carolina Favela and I am the tech lead for the Topographic drone. Now we're going to take a closer look to the LiDAR system. The LiDAR system consists of a computer called the i7 processor and the LiDAR called Intel FuelSense L5 LiDAR. Some of the things that you will need to operate the LiDAR include an operating system Ubuntu 18.04, and it needs to install RRS within that program. You can see the camera that is able to take 2.4 million point clouds in real time. Right now it's capturing all of the point clouds in the room. Some of the future work include taking this system and is able to mount it into a drone and be able to capture the 3D image of a forest. Thank you.